because that's an important fact. All right. So our horizontal acceleration is 0. It is a very important thing for this problem. So I'm going to write that up here. So our delta x is 1,000 meters. Our acceleration horizontally or left to right is 0 meters per second squared. Okay? Our vertical acceleration, or our up and down one, is 9.81 meters per second squared. Okay? Now, this just made this problem a whole heck of a lot easier, right? Okay? So that goes away now. That leaves us with just this. Okay, so this is our vertical horizontal velocity and our time, and we know our change in position horizontally, so we know it's 1,000 meters to the target. Okay? Good? So when we get nice simple equations like this, it's a good thing. Okay? Alrighty. So I think I have these backwards. No, I have this backwards. This should be horizontal. Sorry about that. Okay? Alrighty. You guys have any questions so far? No? All right. Notice that so far I've gone through and I put a V for our X here and H for our X here because our distance that we travel in the vertical and horizontal directions is going to be different, right? We know here this is 1,000, but we have no idea how high up or anything we go. Good? Okay. Our time, or actually, let's go back. Our velocities should have these V's and H's as well, because our horizontal velocity, even though it's our initial velocity, is different than our vertical velocity. Okay? Good? I have not done that with the time. The time is the same for it going vertically or horizontally, right? Because it's in the air for the same amount of time, regardless of what direction we're talking about. Okay, so the time is kind of the thing that connects these two sides. Good? Okay. All right, so now we need to start kind of getting rid of some of our variables. Okay? So theta, we do not know. T, we don't know. V, our V's, we probably actually can use another equation to help with this. Can you guys think of another equation we can do with our V's that would help us have another equation to solve for our V's? Hint?
Pythagorean theorem.
Pythagorean theorem, okay? So this is going to be something that will once again bridge both of these. It's not going to be unique to right or left. So we can say that our hypotenuse, which is V naught, is going to be, let's leave it as a square form. I think that'll actually be more useful in the long run. Our vertical velocity plus squared plus our horizontal velocity squared. Good? So now we can go through and get rid of one of our things here. I'm trying to think which one would be the easiest one to get rid of. Let's leave V naught vertical because time is going to be thrown in a whole bunch of other places. And so if we made this, if we solved this for V naught V to get rid of V naught V, that would mean that we'd have a lot more stuff that we're subbing in. You guys kind of get the logic behind that? Okay. So if we solve for horizontal, it's not going to be hard to solve in or sub in the whole square root here, or really particularly hard there, and we're probably not going to be substituting those in anywhere. Cool? Make sense? Okay. All right. So let's solve for our horizontal velocity. So we will get this. So our horizontal velocity is equal to the square root of v naught squared minus v naught vertical squared. Don't forget that you have to subtract these before you do the square root, so you can't just get rid of these squares. Good? Because a lot of people forget that and do that, and then everything's wrong. All right, everybody good with this? Okay. So now we've got some substituting to do. So let's see how this changes things. Okay, so that hasn't made them too ridiculously much more complicated, right? I mean, it is more complicated, but it's not ridiculous. So now we have completely gotten rid of one of the variables that we didn't know. Okay, so we have completely gotten rid of our horizontal velocity. We've got everything in terms of either our initial velocity that we know or our vertical velocity. Good? Okay. We still have too many variables. So I guess I should add these to our list of unknowns. So we've gotten rid of that one. We have our time, which we can substitute in for in terms of our initial velocity. So we can get rid of time. We haven't done that yet, but we can. Okay. So we're kind of stuck with this whole thing here. We should have enough equations that once we solve them, we can substitute stuff out. Good? All right, so let's make our time substitution. Oh, I forgot time here. In for these guys. Trying to figure out where I want to write this. So let's do, I don't know that we'll actually need this one. We'll see. We might not need that one. Let's put our time into this one because this is by far our simplest one for our horizontal stuff, right? Yeah. And then we should be able to actually solve for our vertical V naught, right? Because we know this, and then this will be in terms of our V naught and our acceleration. Okay. We are going across here, so our acceleration here, I guess it should be horizontal, is going to be that of gravity. Cool. Actually, now that I think about it, do you guys want me to, instead of putting a sub h, just use g as our variable, so it's a little less confusing? Okay, so I'm going to go back and do that. We'll call this g, and we'll call this g. Good? Any questions? No? Okay. So we're going to solve or sub this in for our time here, because like we said, time is going to be the same on both sides, so we can go back and forth with this time. So that's right. Good? Now, we expect to get two completely independent answers, one where it goes like really high up and comes back down, and one where it goes almost flat and kind of hits it that way. Okay? So having something where we've got square roots and squares is completely expected, right? That's exactly what we would want to see. So this is actually a good thing that we've got all these squares and all that going on. All right, so now we need to solve this for V naught vertical. So we get to have fun solving an equation. You ready for that? I know you look so enthusiastic. All right, let's see here. So we're gonna flip this over to this side. So we multiply by the reciprocal, like so. This is gonna allow us to just square this side to get rid of the square root. So we're gonna end up with this squared. This is gonna go away. Good? Am I doing this too fast or are you guys following along? Good? Okay. Alrighty. So we're gonna need to get all of our V naught V's together. So we're gonna collect our terms together. Let's see. I'm running out of room, and that's my problem. So this is going to be squared here. So we have 4 V naught V squared, right? So we were going to multiply this side by that. Let's see. Wait, that's not right. That would be true. Can you guys see that at all? Or not at all? Because we're going to have to start erasing stuff. Can you kind of see it a little bit? Okay. Can I erase the target part of this? Because that's not a super important part of our picture. I'm going to move this guy over here. Actually, maybe I'll just do my work over here. You guys good with that? Okay. I don't want to erase these though. I'll just make it small. Okay. Cool. So no. I'm going to need more of this. I need a bigger whiteboard. All right. Everybody agree with this equation? Did I mess up any negative signs? I did it fairly quickly. So we went from here to up there. Good? All right. So we are going to have to use Pythagorean theorem, most likely. I don't see any easy way to factor this. You guys see any easy way to factor this? I don't really see one. So, in the sake of time, since we have a 30-minute class, I'm going to use the computer to solve this. I will tell you right now, probably one of the easiest ways to put this into a computer or a calculator, because you can solve it with a graphing calculator too, is say, this is A, this is B, and this is C, so that you don't have to try and type out all of the different things. And just remember that this is constant A, this is constant B, this is constant C. Good? Because we know that this is 8. It's -8, but we know it's 8, right? We know that this is B, okay? So it's just a constant, it's just a number. And then this is C. In some cases, it is actually going to be easier to keep the negative sign like in between things. So I'll probably do that so this I'll just have A be 8 instead of -8 and keep the negative out front. Good? So I'm going to type this in. I like to use one called Wolfram Alpha, if you guys have ever seen that or used that. All right. So, yeah. We end up with our classic plus or minus sort of thing. We're actually getting a whole bunch of different answers. Have you guys solved for this? Because I'm getting 4 answers, which makes sense because it's to the 4th. Good. So 2 of these answers are probably going to be ones that won't make sense. So they could be anything like, trying to think of what wouldn't make sense. We could get a negative velocity, and in this case, a negative velocity is not going to make sense. So we can just automatically throw that out. We could get, trying to think of what we could get. Yeah, so there's probably going to be ones that don't fit in with our other equations. There's probably going to be ones that are negative. Actually, yes, there's one that's negative for each one. So, yeah, those aren't going to work out. All right, so you ready for our wonderfully beautiful solutions? Have you guys pulled them up on your computer?